So, I'm going to try and convert my petrol-driven strimmer machine into an electric one. This huge engine, this big petrol motor, which hasn't worked properly for years, is going to be replaced by a pathetic little electric motor, which comes out of an old Black & Decker, I think it's Black & Decker, no, Qualcast, an old Qualcast battery-operated hedge trimmer. So first thing I'm going to do is take all of this to bits, and I'm not going to bore you with taking it all to bits, but I'm just going to dismantle it all, and we'll see what's underneath all the plastic, and see if there's anything useful. Well, that bit comes off. So 2 screws undone here, 2 more to do underneath, and we'll see what's underneath this snout. And we'll have a look. So I've taken out the 4 screws that hold this bit on, and we'll just take this off, and we can see, so there's the 4 screws that are a bit rusty, so they took a while to undo. Right, so what we've got here is the flexible drive shaft. You probably can't see it. There is a flexible drive shaft that couples onto the tool. So we'll need that for the new electric conversion. But what I really want is this bit, because this I want to be driven by the small electric motor I've got. First of all, we need to get to the other side of this. It feels like it's the clutch inside there, some sort of little flywheel. It wouldn't hurt to keep that, actually, so maybe we can use that. So now I think we've got some screws that hold this thing on, and we'll have a look at that. So we'll take those off in a moment and reveal what's behind it. Okay, so we've taken the screws from that and lifted this up. There are some little locator pins which fit into the frame, so you could make it a little bit trickier to pull out, but not very tricky. And obviously here's the clutch, which I presume is yes, because of the spring. Oops, I keep moving. Sorry, I don't do cameras very much. I presume this is a centrifugal clutch, so when it goes fast, these spring out, I suppose. These springs keep them in, and they engage with this little drum here, which is the bit that I'm after. So I'm going to make that bit. I'll keep all of this, I think, most of this. I'm going to make this bit part of the new arrangement, which means we can get rid of all of this, the tank and the piston and the really dodgy carburettor, which has never made it run very well. So there we are. The thing I really hate about it is the noise. I don't like the noise, don't like the smoke, don't like the smell. I don't like playing with petrol. So I'm really quite pleased to get rid of it. However, I've got to make the thing work. So I shall show you the electric motor in a minute, but first of all I'm just going to take this whole shell off, and we can see what we're going to do with it. So a bit of tidying up to do, and we'll have a look at it again. So the purpose of the exercise is to replace this hand-sized, sort of loaf of bread-sized motor, which is the single-cylinder motor, which we don't want anymore. We want to try and replace it with this little thing. So there it is. That's the motor, and that's the motor. That's the old motor, and that's the new motor. So yeah, I wonder if it's actually going to work. I shall let you know. These are quite powerful little motors. I think this is what's called a 775, but it doesn't have a number on it, so I can't. Well, it's got something there. What's that say? Ember East, 18 volt. I don't know. 20 volt. Does that say? I can't keep my hand still. Whatever it says. We're going to. I know it works off 18 volts because that's what the old NiCad battery that used to power it used to have. So this goes. Thank you very much for years of really irritating service. And then this is going to have this stuck in it like that by some means or other. Not quite sure how we're going to do that yet. So that will drive that. That will have the snout put back on again, and then that will drive the tools. We shall see. So this is the handle of the old hedge cutter, and it's got a battery holder in it and a useful looking trigger. So what I'm thinking of doing is, whilst I'm working out how I'm going to mount the little electric motor on the old clutch plate, I'm going to look at how I can, whether or not I can modify this battery holder to work with the battery for this mobile drill, which is also an 18-volt battery. I don't want to damage it because this is my little tool. It's only a cheap one, so but it works. But that 18-volt battery has a very similar looking, but not identical, unfortunately, connector. Hold on, let's just show it to you. So here's the battery, and you can see it's got 3 pins and a slidey thing. Hi! Somebody's back. So 3 pins and a slidey bit. And this has got a slidey bit and a couple of pins. And obviously they don't actually marry, but that sort of slides in. So I think we could actually modify that. I mean, it's sort of, it slides on but doesn't connect, so that might be useful. So we have that's the type of connector we have in the existing drill. Positive and negative. There we are, negative on that on the left and positive on the right. And you'll see that it's not the same pitch. I don't know if you can see, but actually it's not quite the same pitch as the one that we've taken off the old thing. They look as if they might just be, but in fact, when you look at them, they're one line one up and the other one is about half a hole off. So we will take this old one and we're going to chop it probably in half. Yes, chop it in half here, I think. See if we can't fiddle with it to make it work, make it go together, and then somehow magically make it all fit together, and then go back into this this thing, and then this battery will slide in because it fits, as my mother used to say, it fits where it touches. But it actually fits more or less into the case. Okay, it doesn't have a latch, but we might even be able to modify that. Don't know. So it fits into the case like that. Sorta, kind of, sorta. I think this is going to work. It's going to be a bodge, but it's going to work. Hold on, let's have a look at it. Yeah, I think if we just add a bit of plastic coming down from that green bit to snag that little red triangular bit just there, then that battery can be made to lock in place to this, and then we'll have a device which locks the battery into place. Fiddle about with that connector so we can make the connector. The battery isn't quite long enough to go to where the connector originally was anyway, so it's going to have to be in a new position. So I think we can do it. Might have to do a bit of 3D printing. We might have to do a bit of other bodgery. Oh, I was thinking about this other thing. Hold on, let's just move this around. So what I'm going to do, using a bit of the old hedge saw, rather than have to go to the trouble of taking the cog off the motor, I might as well use the assembly it came with. It had a reduction gear, which is roughly 3-to-1 reduction gear. This turned another big cog, which is a bit greasy, so I'll put in a box. Hold on. There. So that slid onto there, and that off-centre bit is what drove the blades up and down, but we don't need that. But I think this will go into here. So what I'm thinking of doing is effectively filling this little cup with plastic. I'm going to make a 3D insert, going to make a 3D printed insert, basically a chunk of plastic to go in there, with a hole in the middle, and that hole in the middle is going to be exactly the same as that cog, the smaller of the two cogs, so that it will fit snug. That stalk, being long, will fit into that hole, so I'll know it's centred, and then I'll be able to drill a couple of holes and to lock the plastic in place by some means or other, so that I can transfer power from this motor through that, reducing it a little, which I think will be a good thing anyway, through this cog, through to that drum, away to the tools, and I think that's going to do it actually. So I'm going to have a go at all that. The other way of doing it would be to take this this cup thing off the clutch, get to that brass bushing, and somehow connect that brass bushing to the to the cog, or either the reduced cog or the direct drive. But I don't have any means of heating it, and I don't want to do that. So I just want to have a go with it like this. So that's what I'm going to do. So there we are. It's a couple of botcheries to do. Botchery the battery connector and botchery the drive coupling. So meanwhile, back at the electrical section, I've taken that connector and I've chopped out half of it, or half a connector's worth, and I've also taken out one of the terminals that needs cleaning. Where are you? There you are. Yeah, it's got a bit corroded, that old one, so we'll give that a little clean. I think a little vinegar and something will sort that out, just to get the corrosion off. It's not very bad, probably just give it a scrape actually. Right, so this is the one that goes in here, and it fits. Not so easy to do it with one-handed. I could get a tripod or something. That would be sensible, wouldn't it? And that's the connector for the other one, and if that goes in there, and you can see that the two actually fit remarkably well. There we are. They work remarkably well if I use two hands actually. It's quite. I might trim a little bit more off, but I don't think I will actually, because when I put them both in just now, there we are. Ugh. Anyway, doesn't matter. I can get them to fit really rather well, and then I'll just create some sort of some mechanical joint that holds them all together. That is a little narrower, obviously, than it was before, but it will still, these two little chunks of plastic here, you can't really see them there, we are. These two little chunks of plastic still fit into the, yeah, there we are. They still fit into the grooves in the case. Obviously a bit loose, so we're going to work on that. But I think electrically we'll be able to plug this battery in. It'll click into place. That'll be cool. Then got to take the wires off, rewire the switch, and actually that's probably right. It's where the switch goes to next that we need to. We don't need it to go down the pole off to wherever it was going. We need it to go to the motor. But we'll sort all that out later. Anyway, I'm quite pleased that looks like it's going to be fitting. The nice thing is that these connectors are virtually identical to the original connectors inside the drill. It's just that they were slightly wider and a different pitch on the carrier, as it were. But the actual plug itself. Right, so we took a picture of the cog and we've taken it into Fusion 360, which is the thing you can get for free if you're just a domestic user and not doing anything commercial with it. And then I sketched it. Let's see if I can recall the sketch. So I got the picture, then I produced a sketch, which probably, yeah, you might just be able to see. If I just get rid of the picture of the cog, you can see I sketched around it. And there's lots of tutorials to say how you did it, but actually just all I did is created one of the little bits, mirrored it, and then made it do a sort of circular repetition of 11, which happens to be the number of teeth. Then I realised, of course, I hadn't bothered scaling it to start with, so I then had to scale it, but it wasn't a problem. I extruded the thing, scaled the image, and you can now see that we have a sort of cog. And I'd drawn it enormous because I then drew the cylinder. Let's just make that a bit smaller. I then drew the cylinder I wanted it to go into somewhere. Maybe I did that. Oh yeah, I got the get rid of that one, and then I created the cylinder I wanted it to go into, which is just a block. And if I put the cog back, you see the cog is sticking out, and then get rid of that. I then subtracted one from the other, and I end up with a block with a hole in it, which hopefully is about the right size. So that should be the size of the clutch drum, and the hole should be the size of the cog. Exported that into an STL file, and then took that over to my 3D printer, where it is busy 3D printing it. There we are. We can see it's off it's going, and it's going to take an hour or so, and I've got to go out and visit family and stuff. So when we come back, Who knows, there might be a piece of plastic which would be about the right size. Don't know if this is going to work, but if it doesn't work, it doesn't matter. I have several other ideas for how I'm going to make this thing. This is only a 50 or a 60% infill, so it probably isn't strong enough, but it's only just to see if I've got the sketch about right. There we are. Off you go, little printer. Well, this is the piece that's come off the printer, and the idea is that this cog is going to fit inside that hole, which it will, and then that is going to fit inside that thing, so we'll have the cog inside there. So there we are. That's a nice tight fit inside there, and then the idea is I'm going to put a screw or something through the side. So I could have made this a bit tighter, but I don't think that matters very much. We're not talking for clockwork precision, are we? So the idea is that this is going to slide onto there. Bingo, bango, bongo. There we are. That's the motor is going to turn that cog is going to turn that drum, and that drum is going to turn that. You can't really see it, but there is in fact a square hole in there. Go on, be square. Yeah, well, there is a square in the hole. Take my word for it. You can trust me. Oh, there it is. You can see the square hole nicely now. And that's what drives the tool down the tube. So the next thing to do is to modify this. There are a couple of slots on the top. So what I might do is just see if I can put a couple of screws in through here. Now, as this is 3D printed, this isn't absolutely solid. This stuff is, I've actually only set it to, I think, 60% infill. So this is a sort of honeycomb structure inside, really. And it may not be strong enough, and it may be that the whole thing just breaks when I put power on it. And it certainly may not be strong enough to hold a screw, not that type of screw really, but just a screw going down sideways. So as soon as I start putting force on it like that, it might just tear. I was thinking of putting a screw into it that way, so at least it's going through more layers. But who knows? Don't know. I like the idea of not modifying this. For some mad reason, if I wanted to, I could just about put the whole thing back the way it was. I really don't want to, though. But because I've got these two slots, it sort of seems to me that it would be sensible to have screws there, and maybe probably a step too far, but just wondering if there was a way of putting some sort of shock absorber in it, so when the machine jams against something, this could spin slightly and against a spring. Probably a bit too far, really, a step too far, especially as that there is actually a shock absorbency built into the flexible drive shaft going up the pole of the tool, whatever it's gone to. This thing, this is actually a sort of spiral metal thing, so it's actually got some give in it. So maybe the thing to just get a couple of screws and shove them through there. We shall see what we shall see. So anyway, that's the next stage. But I'm quite pleased that the drawing and 3D printing and all that stuff has come out okay. Anyway, if this didn't work, there are plenty of other options. If you don't happen to have a 3D printer, there's no reason why you couldn't fill this with epoxy or something and just set that in it, or something else far better. Anyway, that's what I've done. Well, I was wondering how I was going to join these two halves of the connector together, and then I thought, well, why don't I just hold it in place with a glue gun? But actually, it's actually remarkably strong. The glue gun has stuck very well, so I'm sure it won't be permanent, but it certainly seems to be pretty effective, and so that will do for that. As you can see, it's a very high-class piece of precision engineering, in keeping with the rest of this project, but it doesn't really matter very much. It's all going to work, I think. So now we have to put the connectors back in the right places, which we'll do. These particular ones are easy because they're just a sort of push fit through the hole. So I don't know if you can see the hole there. There we are. They just push into place, and the whole thing slides into the battery quite well. So there it is. Whoops. There we are. So that's going to work as well as it needs to, really. So I don't know how long it'll last, whether it'll... it seems to come in and out perfectly well. So there we are. That's the electrical plastic adapted. We've now got to work out how we mount that into the handle and handle onto the box. But For now, we need to return our attention to making the this device sit inside the shell, sit inside the housing. So that's got to go into here, and extraneous bits of metal got to be taken away, and the whole thing's got to be made secure. Now, I don't know how I'm going to do it, so we'll scratch our brains and I'll tell you what idea I came up with. It'll be a bodge, though. Of that I suspect we can be certain. Here, and that makes a really good fit, but it's not really necessary, and I'm going to have to do some jiggery-pokery with this metal, and I suspect it's going to be quite awkward. So I'm going to have a quick detour, mental detour, have a look at modifying this case so that spout sticks out. I think this device could be made to attach to that device relatively straightforwardly, and if it can, we might actually have a better solution, or just a better interim solution. Obviously this casting is designed, this plastic casting is designed to hold that motor wherever it's gone to. Here it is. The motor slots in there. So it is all designed to fit. So I think we might have a go with it. I mean, the thing is, I'm only going to be chucking this away anyway, so I might as well have a go at seeing if I can adapt it. And if I can, and it's strong enough, then that saves chopping up a load of bits of cast metal. And the thing, I'm a bit worried about chopping cast metal because it isn't that strong. So, yeah, I think that's probably going to do it. So we'll have a look. We'll create a new opening here for this to pop through. We'll see if we can create some screw holes and possibly get some strengtheners of some sort, so that the red bit at the end of the tool can be screwed to here. And then all I've got to do is work out how to get the battery mounted and the power control mounted in a sort of neat and effective way. Anyway, here we go. Well, the zombie tool is now finished. Well, finished-ish. There's a couple of things I'll improve, but the battery is now held on. That's going to be a piece of plastic eventually, but it's a piece of metal that just holds the battery in. The battery clip is working. It just needs to be secured, but you can unplug the battery and plug it back in again using that connector. I used the handle of the existing box, and I might still do something better, but it seemed very straightforward. Just get the handle with the wiring in it going to the motor. So that's all contained in here. The original switch, which has got a nice interlock to it, fits on quite neatly simply by putting a pipe clamp. There's one that was part of the original hedge cutter, and I've temporarily just screwed it on with a sort of little plastic P-clip. You can't quite see it, which goes through underneath there. You can just see it's a P-clip. It's a bit flexible really, so I want to make that a better clamp, or possibly cut this at an angle, screw it onto here neatly, but since I'm not convinced I can do it neatly, this will do probably for the time being. And the thing I'm not proud of is the fact I'm using a couple of cable ties to hold it together, but that will be, I'll get a nice piece of plastic that I'll probably print or fashion in some way that fits in here, so it just holds it a bit neater. But essentially the whole thing is together, and it spins this thing around really well. And it's night time now, so tomorrow I'll show you it working. But here is the zombie whatever it is, the zombie weed whacker. So there we are. Well, I'd say that's a success. The little Frankenstein strimmer strims okay. The principle works perfectly. That ridiculous little tiny motor that we saw at the beginning replaces that huge petrol motor, and okay, it's a bit of a sort of Heath Robinson attachment, but with a bit of effort you could actually make it into a very lightweight small tool. I'd say, you probably heard in the video, that the little 18-volt battery probably isn't quite powerful enough, and I think a slightly larger battery would be better, but it may just be because that battery's not very good anyway. My hand drill doesn't hold its charge very long, so it could be just that. But I think overall that is a real success. And I didn't show you on the video, but the blade you probably saw when I was in the workshop, which is for chopping brushwood, also works really well. But I just need to do some strimming today, so that's what I've got on. But it works. There we are. So the question, can you replace that enormous motor with a tiny little electric one? The answer is yes, you can. And I'm very pleased, so that's a thumbs up.